Hi, this is Mr. Doro. This is part one of our energy calculations video for Swartz Creek Chemistry, and this is going to be calculating how much energy is absorbed or released as we have a physical change of state. So just a few things we got to get straight first before we get into this, and that is this is what energy is. Any type of change needs energy. Then there's this thing called heat, which heat is just a form of energy, and a lot of times when we say heat, we just mean energy. It applies to the mass of the substance, the type of the substance, and the temperature change, and we can calculate the energy needed to be added or released for a physical change to take place, which is what we're going to do now. So this is a heating curve for water. What we have on the y-axis over here is temperature in degrees Celsius. We have energy or time when energy is being supplied, or heat down here on the bottom. Now this is multiple steps for water. This is solid water or ice, and as it's melting, it's increasing its thermal energy. Energy is being stored as thermal energy. Then it has a point right here where this would be 0 degrees Celsius, and this is increasing phase energy, and that's why the temperature doesn't go up. It changes it from a solid to a liquid. This one is increasing the thermal energy of that liquid, heating it up, and this is phase energy. This is at 100 degrees Celsius, where the liquid is changing to a gas. Each of these terms, each of these values are experimental values to see how much energy is needed in that little section right there. So, for example, this first section, it needs 2.1 joules, that's a unit for energy, for every 1 gram of solid ice to go up 1 degree Celsius. Notice I said for every, so these could be flipped around. And then the same thing right here, this is not changing temperature. That's why it doesn't have the degrees Celsius for every 1 gram of solid water. In order to change it over into the liquid water, it takes 334 joules, and you can see the rest of those terms. Now, one other thing too is if you take a look at this number right here, that really means for every 4.18 joules, 1 gram goes up 1 degree Celsius. But what if you had 10 grams? If you had 10 grams, then you'd have to multiply this by 10 grams. And if you had wanted to go up 10 degrees Celsius, you would multiply it by 10 degrees Celsius, because this is for every one and for every one. So that's what we're going to do in the next problem. So this is one type of problem that we might see that we can use these energy calculations in. It says that we have a serving of chips. It releases this many kilocalories of energy, and we can convert that over to joules or kilojoules. When digesting your body, if the same amount of energy were transferred to water, so now we're back to water, at 15 degrees Celsius, what would the final temperature be? So several things that we have to take care of here. One of them is we have to change this kilocalories right here into some either kilojoules or joules, and that is just a simple factor labeling. So that is 110 kcal, and we factor label that, and we get kcal down here, and we get kj here. This is for every 1 kcal, there's 4.18 of these. So I'm going to calculate that. And I got 459.8 kilojoules, which in sig figs I went to 460. What I like to do on each one of these is I like to do two little graphs to see where we're talking about. This one will be temperature versus time. And they both could be that, but just to show that they're different, I'll do temperature versus energy. This one is for water, so it's going to have this shape. And I want to figure out where I'm at on this chart. That it had water at 15 degrees Celsius, and we're adding water to it. So that's going to be right in this section right in here. Now we know a constant for that section. The constant for that section is 4.18 joules for every 1 gram, 1 degree Celsius. And then also we can look up here at the temperature versus time, and we know that we started at 15 degrees, and we're going to call that 15, and we know it went up. Now we don't know where it went up to. That's what we want to find out. Now there is a formula to calculate all this stuff, but we're going to work our way through just by what we know by using this as a for every statement. For every 4.18 joules of energy in that stage right there, it increases 1 gram, 1 degree Celsius. Well, we want to know the final temperature, which is the degrees Celsius. So what I'm going to do is I'm going to rearrange this, and I'm going to flip that over so that I have the degrees Celsius on the top. Whatever I want to find, I want it to start out on top. 1 gram, 1 degree Celsius, and then over 4.18 joules. Now, in order to do this, if we have to get Celsius all by itself on the top, then we need to get rid of this joules that's on the bottom. Now, let's remember this also, that 460 kilojoules, that could also be 460,000 joules. And so that what we're going to do is multiply this by 460,000 joules. What's going to happen now is the joules are going to cancel out. And we have grams and degrees Celsius left, so we need to get rid of the grams. We also then need to multiply by actually, we need to divide to get rid of grams, but I do like to do that by multiplying 1 over. Now, here's our grams right here, but that's in kilograms, 4.0 kilograms, and that would be 4,000 grams. And so then we multiply these through. And when you multiply them through, you need to make sure that you're really starting with the 1 on top, 1 divided by 4.18 times 460,000 times 1 divided by 4,000. This is why I got 27.5119, but that would be in 2 sig figs, because this is 2 sig figs, and that was 2 sig figs. So that would be 28 degrees Celsius. Now, that's not my final temperature, though. That's my change in temperature. Remember, way back here on this side, I started at 15, and I went up another 28, so I have to add those two together. So my final temperature, T final, is 15 degrees Celsius plus 28 degrees Celsius, which would be, my T final is 43 degrees Celsius. So we worked our way through that problem. So now this one is going to deal with a little different part of the graph. It wants to know how much energy required to melt a third of a bag of ice, and it tells you how much was in the bag of ice. That was at 0.0 degrees Celsius. So if we do our little temperature versus time, and we do temperature versus energy. Remember, we had this shape in our graph before. This is water, so it would be the same kind of deal here. And so what stage of this are we at? Well, we're at this one where it's melting. And so we had a number that went along with that. And that number was 334 joules for every 1 gram. And so that's the factor that we're going to be using in this. Now, if we go back to the time, temperature versus time, we can see that we have a flat line. So that's going to be a flat line at 0 the whole time. And the whole bag's not melting, only a third of the bag. So we're going to start out our calculations. We want to end up with energy. Energy is joules, so I'm going to start with that factor with the joules on top. 334 joules for every 1 gram. And then I have well, I'm going to find out, really, there's a couple ways you could go at this. You could find out how much total energy it would take, and so that's what I'm going to do. If all 2.25 grams of that, or kilograms, got melted, then we would have to multiply this by, remember, this is grams down here on the bottom part. We would have to multiply by 2250. I changed it over to grams. There is another way you could do it, too. You could think of this as 334 kilojoules for every 1 kilogram, and the way that would look is this. You would just start 334 kilojoules, 334, sorry, for every 1 kilogram, and you would multiply that by 2.25 grams, or sorry, kilograms. So I've calculated both of these out because the kilograms cancel here, the grams cancel there. This one ended up with 752,000 joules. This one ended up with 752 kilojoules, which really mean the same thing. And so, which a lot of times when we get to the big numbers, we put it in kilojoules. But that's to melt the whole bag of ice, to get it all changed over. And we only wanted to melt a third of it. So how are we going to find how much energy it's going to take to melt a third of it? Well, we take a third of each of those numbers, or divide them by 3. We divide them by 3 or multiply them by 1/3, and we get, on the top one, we get 251,000 joules, and on the bottom one, 251 kilojoules. And so really, they mean the same thing. So 2 different ways to look at that. You could have also taken 1/3 of the mass right away, and you could have found the same answer too. So a couple different ways to do this, but notice we didn't really use a formula. We just did what we know, and we knew this was for every 1 gram, but we knew we had 2,250 grams, and so we multiplied it together. Okay, so now if you are doing this for any type of a retake and trying to make sure that you understand this, or you're just trying to practice this on your own, here are 3 problems that you could do, and you could make sure that you're in the right area. and go ahead and find out what that is. Use the correct factor each time, and then work those out. So good luck to you.